Yes, so we have, this time we are given the general term. That's nice. We can determine any term of the sequence. So negative 1 raised to n plus 1 divided by 3 to the n minus 1. Okay, so a1, 1 plus 1 is 2, negative 1 to the second power is positive 1, 3 to the first power is 3, minus 1 is 2. a2, 2 plus 1 is 3, but negative 1 to the third will be negative 1. And 3 to the second power is 9. 9 minus 1 is 8. So this is negative 1 over 8. A sub 3. 3 plus 1 is 4. Negative 1 to the fourth power is 1. 3 to the third is 27. 27 minus 1 is 26. Finally, a sub 4. I think they want 4, right? 4 terms, yes. So for a4, 4 plus 1 is 5, but negative 1 to the fifth power is negative 1. 4, 3 to the fourth is 81 minus 1 is 80. So this is negative 1 over 8. And as you see, the terms of this sequence are alternating terms. Positive, negative, positive, negative, positive, negative.
Can we do 16?
Yes? 16, let me see what 16 is all about. Okay, so we have a function. And the function is f of t. 110,000 over 1 plus 5,400 e to negative t. How many people became when the epidemic began? What does that mean? Initially, what are we asked to determine? When we talk about initially, what do we mean?
The starting value.
Yes, meaning f of 0. Initially means when time is 0. Then the fourth week, okay. And then what is the limiting size of the population? In other words, when, f of 50 weeks, f of 100 weeks, and so on and so forth. When time passes, what really happens? So for this problem, I will put everything in the graphing calculator, except for f of 0, but I can, right? It is very easy to determine. So e raised to 0 is 1. 1 times 5,400 is 5,400 plus 1. So 110,000 divided by 5,401. 5401. And I cannot round up because I don't, obviously, even if I had 20.8, I could not round up. I'm talking about people. So 20 people. Now for the rest, I have to put in the graphing calculator. And I highly recommend, instead of repeating the process 10 times, I will put it in. The numerator, it's one number, does not need parentheses, but the denominator is crucial to have parentheses around it. So 110,000 and divide by, in parentheses, 1 plus 5,400, and e is right here. In parentheses, that's me, negative x, and then come down. So I put not just this in parentheses, but you have to put this in parentheses. And now we go to second and table, and I plug in all these numbers. Of course, I can check my work with plug in 0, I get 20 people. When I plug in 4, I get 1,101 people. And this is really what we are going through right now. Okay, so now if I plug in 50, and if I plug in 80, and if I plug in 100, and if I plug in 120 weeks, you see what happens? The limiting size of the population is the numerator. So as t increases, f of t cannot exceed 110,000. They were also on lockdown. No one came in, no one went out. So the most number of people that can get sick is the number of people living in the town. That's why they did what they did with us. Unbelievable. I never thought we would go through this.
Can we do number 11?
Sure. Number 11. Okay, so I think we solved this last time. Let's do it again. 9 raised to x plus 8 equals 81 raised to x minus 8. So,
is it x plus 8 or x plus 6? It looks like x plus 6 on the thing.
Yes, you're right. So I think, as I said, we did this last time and I copied the same thing, if you remember. So anyway, 9 raised to x plus 6 equals 9 squared raised to x minus 8. So the left-hand side, and here I copy and I have to multiply. So this is 2x minus 16. And the same thing, like always, two numbers are equal, they have the same base, their exponents have to be the same. So then x plus 6 must equal 2x minus 16. I subtract 2x, and I subtract 6. So x equals 22.
We do number 15.
Yes. Number 15. Okay, so t equals 0 is 2003. T equals 0 represents 2003. Use the model to determine the population of the country when it will be 733. So 733 equals 543.3 times e to 0.02 t. So, of course, I have to clean it up first. I will divide both sides by this number. So 733 over 543.3 equals e to this. And now we have to bring down the power, so I have to apply natural log. So I apply natural log to the left-hand side. And when I apply natural log to this side, I get 0.02 t. So then t equals. Do not divide, there is no need. We have to keep it like this to get the best approximation. So natural log at the top, and it's 733 divided by 543.3, and divide everything by 0.02, and we get roughly 15 years. Which means 2018.